Okay, so I'm going to run through just sort of the basics on this. I actually don't do anything different than what you would have done in trig. So let's just kind of remind ourselves how to plot points and everything. So a polar coordinate has coordinates r theta. When you go to Calc 3, you're actually going to learn two other coordinate systems too. You're going to start getting into 3 dimensions, and you'll learn about what's called cylindrical coordinates and spherical coordinates as well, where you have, 3 things like an x, y, and z axis going on there. So this is kind of, will get your head wrapped around that a little bit, hopefully, when you get to that point. So let's just plot points. Really, all you're doing on polar coordinates is you have angles just like you would have on a circle, and then you have a radius. So it's always r and it's always theta. So it's real easy to plot points. So what you do on this first one is you just locate pi over 6. If the radius is 3, you just go to the third circle and put a dot there. So let's just plot points first of all real quick. Okay, the next one, 7 pi over 4, is here. Now, if it's a negative radius, what you do, you don't go towards it. Negative just means the opposite direction. So don't go that way. Go in the opposite direction, out 1, 2, 3, 4, 5 there. So you're going out to the 5th circle. So that's where the second point would be located right there. I'll label that as the second point, and then this one is the first point like that. So if it's a negative radius, you just go in the opposite direction. Okay, the next one, negative pi. Negative pi would be clockwise, like you know there. If it's a positive radius, you go towards that. So you're actually going to go to the left, so that's where that third point is. Okay, like that. Okay, then this last one, negative 4 pi. Where is negative 4 pi, by the way? It's clockwise, and where do you end up? 0. Yeah, just there, right? Every lap is 2 pi. Well, if the radius is 0, where would you be? You just be at the origin, okay? So that's where that particular point is. So actually, what's weird about polar coordinates is if I have a 0 and then anything, there's an infinite number of ways to write the polar coordinate for the origin 0, 0. In fact, there's an infinite number of ways to write all of your coordinates, because there's an infinite number of ways to write your angle, and then your radius can be positive or negative, okay? Does that look okay to everybody? Okay, you learned this in trig. You probably haven't done any of it since, though. So let's do a couple more of these, and then we'll kind of get into equations and stuff. So let's see. This one is 245, so you just go out to 45, which is in here. If it's a positive radius, what do? You go towards the angle, so that's where that would be located. And your angle can be in degrees or radians. It doesn't matter. Okay, 540. If you subtracted 360 from 540, you'd get 180. So for all practical purposes, you're there. And then you would just go out to the 5th circle. So 1, 2, 3, 4, 5, we'd be out there somewhere, okay, wherever the 5th circle is, like that. Okay, then the next one's 210. Now, which way do you go if it's a negative radius? Do I go towards or away? I go away. So that would be like that. So that's all there is to plotting points. You guys remember that, learning that at one point in time? Okay, all right. Okay, so the main thing we're going to work on is just how to write points in different ways, and then converting coordinates would be kind of the big thing I want to do on here. So let's go ahead, and I want you to draw a diagram on this. Okay, so we want to kind of go over these substitutions. And a lot of you, I think, took physics this semester. Did x equals r cosine theta and y equals r sine theta show up a lot? Do you guys do mechanics and ramps and stuff like that?
We didn't use it as polar coordinates, but we did use...
But you used that substitution some, didn't you?
Yeah.
Okay, that's what I was thinking. It's been a long time since I've done physics, but I remember... That shows up a lot when you're doing like mechanics problems and stuff. Okay, so here's what I want you to do. Is just draw like an XY axis like this, and then put a dot just somewhere in here like this, and then we're going to call this dot r theta. That's a polar coordinate like this. Okay, then let's draw a radius to that point and label that r. Okay, so remember in polar coordinates, you have a radius, and then you're at some point on a circle, okay, like that. So this is theta, And then you want to just go straight down to the x-axis to make a right triangle. And what happens on this is this value right here would be the x value of that right triangle. This value right here would be the y value of that right triangle right here. So in polar coordinates, the reason we teach this in trig is because it has a lot to do with trig. So first of all, what you get is the cosine of theta. We know that's x over r, right? Then if you multiply both sides by r, well, you get this substitution. You get x is equal to r cosine theta. And then if you do this, if you do sine of theta, we know that's y over r. So now if we multiply both sides by r, we're going to get y is equal to r sine theta. Now the way I remember this is not anything new. This is just the definition of cosine and sine solved for x and y, right? That's all that is, okay? The other thing that you know is in my triangle, what's x squared plus y squared? R squared, okay? That's just what you learned in trig. That's Pythagorean theorem like that. So these are your polar substitutions if you're going from one system to the other. When you go to Calc 3 and you start working with spherical and cylindrical coordinates, you do something similar. You have substitutions to change coordinate systems, okay? And oftentimes it makes the calculation a little bit simpler then. Okay, so what I want to run through on this is I'm giving you a polar coordinate, which means that I'm giving you a radius, and I'm giving you theta. So we want to change this to a rectangular coordinate. Okay, so this is all you have to do on this. You just do x is equal to r cosine theta. So in this problem, r is 5. Then we're going to do the cosine of 2 pi over 3 like that. Okay, and then we just got to look that up on the unit circle. You don't need to refer to a unit circle. You can just figure it out. I just do this like this. So basically, if you want to convert that, there's several ways you can do this. 180 over 3 is 60. That's really a 120-degree angle. So you're really at this point on the unit circle. What is this point on the unit circle? What's its x value? Negative 1/2. How high is it? Root 3 over 2. Okay, you want to just kind of create that on the fly. You just have to keep doing that in math classes when you're dealing with trigonometry. So what we have is the cosine, of course, would be the y value. So that's 5 times negative 1/2. So that would be negative 5/2. So x is equal to negative 5/2. Okay, like that. Okay, then you go to y. What's the substitution for y? Y equals r sine theta. And the way I remember that is the sine's y on a unit circle. The cosine's x on a unit circle. So, and if r is 1 in a unit circle, that's what y, x and y are. So what you're going to have is the radius is 5. Then you're going to do the sine of 2 pi over 3. So that's just going to be 5 times the y value, square root of 3 over 2. And if you multiply straight across, you're going to get 5 radical 3 over 2, like that. Okay, so what we're done then is that polar coordinate is the same as this rectangular coordinate. Okay, like that. That's your answer to your problem. Okay, they locate the same place. If you graphed this in polar and graphed this in rectangular, they're the same. You can superimpose a polar system on top of a rectangular. They still locate the same thing. Okay, does that make sense to everybody? Okay, that's pretty easy. You'll do even this on the final. These are some of the gimme problems, okay? So we'll have a few things like the parametric like we did today, and a few things out of this section, okay? Just to kind of make sure you're on top of this before Calc 3. Okay, so on number 4, let's see, I give you r as negative 3. I give you theta as this. So it's the same thing. X is going to be r cosine theta. Y is going to be r sine theta. So all you do is just work it out. Whatever you get is what you're going to get for your rectangular coordinate. Okay? So we get x is equal to r is negative 3. Then we're going to do cosine of 3 pi over 4. And over here we have y is negative 3 sine of 3 pi over 4. Okay? Now 3 pi over 4, if you look it up on a unit circle, you are in quadrant 2. You're actually at that point right there. Okay? What is that point on the unit circle? Negative root 2 over 2. positive root 2 over 2. That's actually 135 degrees is what that is, okay? So what you do is just work out the cosine. You have negative 3, negative root 2 over 2. So that's going to be 3 root 2 over 2 for x. Okay, then you do y. Same thing, you'll get y equals negative 3, but the sign is positive since you're in quadrant 2. So that's going to give y is equal to negative 3 root 2 over 2 like this. Okay? Now, what we do is we write this rectangular coordinate then as 3 root 2 over 2 for x, comma, negative root 3 over 2 for y like that.
I think your R, you were supposed to go away from the center. I think you went.
Let me show you. That's what I was getting ready to show you is that you might be thinking these aren't matching, but they do, and here's why. Okay? One thing that's kind of a good thing to do on these problems is make sense of the quadrant you're in. If you plotted this point, well, there's 3 pi over 4, right? Okay, but what quadrant would you end up in if the radius was negative? 4, exactly. You wouldn't go that way, you would go this way, right? That's where that polar coordinate's located, is in quadrant 4. Does that make sense to everybody? Now, where is the rectangular located? Well, you have a positive x and you have a negative y, so aren't you also going to end up in quadrant 4?
This will be negative 3 by equal 3 over 2.
That's, I think what I'm missing is that y value. I didn't write that right. But I do have the quadrants and signs right, so this is negative 3 root 2 over 2. Does that make sense to everybody? Okay, if you plot this polar coordinate, there's 3 pi over 4 right there, but negative radius makes you go to quadrant 4. Well, that's what we got. So I always recommend when you do a translation, make sure that your quadrants match up. Okay, just as kind of a quick check. That also helps you understand how this works anyway. It's the same thing. Okay? All right, any questions with that? That's real simple. Just r cosine theta for x, r sine theta for y. Unit circle stuff primarily. Okay? All right, let's do one more of these real quick. Now, let's do a little graph on this one too. Okay? All right, 120 is this point right here. Okay, and on the unit circle, that is the point negative 1/2 root 3 over 2. The way I always reason that out is y is big, x is small, okay? And then this point right here would be negative root 3 over 2, 1/2 like that, okay? I remember how to differentiate those things just by a little bit of logic. So anyway, what you would have is this is like the last problem. What quadrant would you end up in on this one if the radius is negative? Okay, you'd be way down there, right? Out at the 9th ring, the 9th circle. Okay, so what we're going to do is the same thing. We have x is equal to r cosine theta. Then we're going to do y is equal to r sine theta. Now, what you expect to happen, since we're in quadrant 4, what would x be, positive or negative?
Positive.
What would y be?
Negative.
So see, it's a good idea to predict. Okay, just kind of make sure that this matches up with where you're supposed to be. So what we do for x is we just do negative 9 cosine of 120. Okay, so that's negative 9. The cosine of 120 is negative 1/2. So see, you're going to get a positive answer. Okay, so we get 9/2 for x. So we got what we expected. Okay, then when you go to y, you're going to have y equals negative 9 sine of 120. So that's going to be negative 9 times square root of 3 over 2 like that. And you got a negative answer like you expected. So y is negative 9 root 3 over 2. So you get a logical answer. Okay, that's it. Okay? All right, so that's one thing that you definitely want to be able to do. And you're going to do this in Calc 3. So we want to review that because your Calc 3 teacher is going to say, hey, polar coordinates, what do you know? So we hope you at least know this. Okay? Not hard to do. Okay, we're going to also do this backwards. So what you do on this typically is if you start with xy, then you already know you have that relationship, and typically a lot of times you use tangent, but you don't have to. So what I'm going to do is just kind of go backwards on this, and this is basically the same idea, so I'm not going to have you draw a diagram on that. So let's just go backwards and write these things, write points in 3 different ways. Okay, so let's take this point, 445. Okay, so that would be like this. Okay, that would be at 45 degrees, and then you would go out to the 4th circle. Okay, so let's write this in like 3 different ways. You can actually write polar coordinates in an infinite number of ways. So let's just do this kind of like this. Let's start with, and it doesn't really matter where you start. If that's 45 degrees, you could also make a negative angle if you want to right there. So if you counted this out, this angle right here is actually 225. If you went this way, that would be negative 90 plus negative 45. So it would also be negative 135, right? Okay, you can go backwards. You can use a negative angle on this if you want to, and then you can use a negative radius if you want to, okay? So to start with, what I'm going to do on this is I'm just going to use a negative angle, okay? So I'm going to use negative 135, okay? So if I do that, I would be going clockwise like this. Now, what would I use for a radius? Because remember, I want to be in quadrant 1. Would I use 4 or would I use negative 4? Negative 4. Okay, so you could do that like that. That would be another way to write that point. You have a negative angle, you have a negative radius. You can do that if you want to, okay? And then there's other ways, okay? You could also do, you can make an angle that's coterminal to it if you want to. You could also use a positive radius with a different angle, okay? So the other thing that we could do is you could do, if you wanted to have that same angle like this, you could just use a negative like this. So if you went negative like this, that would really be negative 315, right? Because that would be 45 less than all the way around the circle. So would that work okay? If you plotted negative 315, you're there. And then if you have a positive radius, you'd go towards it. Is that logical? Okay, that's another way to do it. Okay, and then there's an infinite number of ways to do that. So I've got 2 negative angles like this. Now I could do a positive angle that's coterminal to that. I could also just do 45 plus 360. And if I did that, if I add that up, that would be 405 degrees. So I could use 405 degrees if I wanted to. And then if I did that, you would still use a positive radius. And then there's a bunch of other ways to write that too. The reason that there's infinite number of ways to write a point is why? Because there's an infinite number of ways to write angles, right? So you could write this in different ways. I generally just try to use a couple of negative angles, a negative radius in there somewhere. So there's other ways to do that as well. Okay, does that make sense to everybody? Okay. All right, let's do this conversion here. So let's see, if we do this, we now have an xy coordinate. So what we have is that's x and that's y. Now what I would recommend that you do on these problems always is draw a picture in rectangular, and sometimes just by looking at the picture, you could immediately tell what the polar coordinates are. And there's more than one way to do this. So if you plotted this point in rectangular, of course you would just go to the left 3 like that, and that's where your point is, okay? So keep in mind, there's an infinite number of ways to write this answer. The way that I test on this, the way they say this on my math lab, they might say, we want theta to be from 2 pi to 0 or something like that. And they might include one and not include the other, okay? That might be a part of that. And they might say r needs to be a positive number, okay? So otherwise, you could just be as creative as you want to. As long as it locates it, you're good. Okay, so what could we use for the angle in radians? Pi. Okay, what would the radius be? If you're going to pi, would you use a positive radius 3 or a negative? You'd use positive, right? Because you're going towards that angle. So one way to write the answer would be 3 pi. The 3 comma pi. That would represent the same thing in polar, correct? Okay, is that logical? Okay, so I'm going to use these same directions on these problems. Okay, next one, just do the same thing, draw a picture. Okay, we got 0, 3, that just means we're going straight up 3, like that. So what would be the polar coordinate? 3 pi over 2, right. Okay, you could use the radius would be 3. You could use pi over 2 if you wanted a positive angle. So you just say 3 comma pi over 2 like that. Okay, let me ask you guys this question. Tell me if this would be a correct polar coordinate. If you had negative pi over 2, negative 3, would that still locate the same thing? Yes, okay. So you could write that in different ways, but if I want a positive radius and a positive angle, that's typically the way you do that thing. Okay? Okay, next two you have to do a little bit different thing on. Let's go ahead and run through these and then we'll do the equations and we'll be done here. So with this one, basically we have x and we have y. Like this, and let's go ahead and just draw a picture of it. Okay, the picture kind of helps you understand what's going on, at least locates the quadrant you're in also. Okay, so what you would have is you're in quadrant 4, and what we're going to do on this is we're going to identify this angle. We're going to get a positive angle, and then we're going to get a positive radius like this. So see what we have is we get a right triangle. We get x equals 2, the y value is negative 2, and then we can find the value of that radius like this. So you have to start this problem by finding the radius, just doing r squared is equal to x squared plus y squared. So we'd have r squared equals 2 squared plus negative 2 squared like that. So that's r squared equals 4 plus 4. So that's r squared is equal to 8. Okay, just like you did in trig. Okay, you do that. We're going to use a positive radius, so you don't have to worry about the plus or minus. So that would be 2 root 2 if you simplify that, correct? Okay. Now what you can do from here is this is 2 root 2. You may already know what that reference angle is. By now I hope you have good enough knowledge of the unit circle that you could tell me, what is that reference angle? 45. How do you know? Because the x and y are the same. Okay, if you don't know that, well, the way I do this, a textbook a lot of times will just say use a tangent. You know, I don't do that. I usually just use a sine. And it just, to me, it's just easier to look up a sine on a unit circle than it is a tangent. So we know a sine is y over r. So anyway, y in this problem is negative 2. The r value is 2 root 2. That crosses out, that gives negative 1 over root 2. But that is the point on the unit circle that you're familiar with anyway. That's a 45-degree reference angle, right? So if you looked this up on the unit circle, you would find at 315 degrees, which I think is what, 7 pi over 4, you would find that point anyway. Okay, so what you'd get for theta is you could use in radians 7 pi over 4. So your polar coordinate would be 2 radical 2 for the radius and 7 pi over 4 like that. So most of this is just unit circle knowledge stuff, okay? So that's how that goes. The other way you can do this, if you want to, I do this a lot. I mean, if you can do it in your head, that's also good. I think this one's easy enough to do in your head. But you could also do this. If you went through and divided everything in this triangle by 2, you would get negative 1 square root of 2. Isn't that the 45-45 right triangle? So you can figure it out that way too if you want to. Okay? But mostly it's just unit circle knowledge and where are you on the unit circle? That's the idea. Okay? All right, let's draw a little picture out for this one also. So this one, you're going left and down. So you're basically down in quadrant 3. Okay? And what I'm going to do on this is let's draw the radius like that, and then let's just draw our reference triangle like you did in trig. So x is negative root 3, y is negative 1 like that. Okay? So what we need to do is we need to find r first of all. So you always do r the same way. You do Pythagorean theorem. Okay? You may already know that. Do you already know what the radius is? The radius, not the angle. 2. You remember your triangles from trig, like the 1, 2 square root of 3 and the 1, 1 square root of 2. This is the 30, 60 right triangle is what it is. So if you see that, that's a 30, that's a 60 like that, then you can figure out the problem from there, okay? I'm going to go ahead and just crunch this out real quick. So x is negative root 3 squared plus negative 1 squared. So that's r squared equals 3 plus 1. That's r squared equals 4. So we're going to use a positive radius. That's why I'm bypassing the plus or minus, because I'm making a decision to use the plus radius. Okay? Well, okay, what is the angle then going to be? In degrees, that would be 180 plus 30. So that would be 210. Which one is that? 7 pi over 6? I think that's what it is. Okay. So that's 7 pi over 6, so you would have 2 comma 7 pi over 6. I'm not going to spend much time with the angles because of the level of class you're in. All right, so that's it. That's how you do that. Okay? So does that make sense to everybody okay? Okay, shouldn't be that bad. Okay, let's finish up here with these equations, and then we'll start our review here. Okay, so what we're going to do is just change rectangular to polar equations and backwards like this. So what you do is you use these substitutions. So if you've got a rectangular equation, it's got x, y in it, that's what makes it rectangular. You're just going to replace, everywhere you see an x, you're going to replace it with r cosine theta. Everywhere you see a y, you're going to replace that with r sine theta. And just work out the details. So that's going to give r cosine theta squared plus 4 times r sine theta squared is equal to 4. And generally on these problems, you just do simple things, just little simplifications. So if you square this, you're going to get r squared cosine squared theta plus 4 r squared sine squared theta is equal to 4. Okay? You don't have to go very far on this. The only thing that I would do on this is you can factor out an r. Okay, and if you factor out an r, you're going to get r squared cosine squared theta plus 4 sine squared theta is equal to 4. That's good enough. Okay, you don't have to go any further than that. You've got r and theta in there. And then simplification, there is no one answer to simplification. You can do several things. If you can use a trig identity, you use it. If you want to solve for r, you could do that. But to me, this is good enough. Okay, just go in there. So when you're taking rectangular to polar, you just do r cosine theta and r sine theta. That's it. Okay? You did that in trig also. Okay, let's do these real quick. So what's x? X is r cosine theta. So you would get the answer r cosine theta equals negative 3. That's good enough. Okay, that's all you do. The next one, y is r sine theta. Okay, x is r cosine theta. So you're going to get r sine theta is equal to r cosine theta. And then generally it could be written that way, but you could also divide by the variable r because it isn't going to make any difference. Okay, so that gives sine theta is equal to cosine theta. Okay, now one thing I like to kind of see on this, if this makes any sense to students, what is the graph of y equals x? What is that, by the way? It's a straight line with what angle? 45-degree angle. That's what that is. If you have a slope of 1, like you have there, well, where on the unit circle is the sine and cosine the same? What is special about 45 on a unit circle? Aren't the sine and cosine the same? Yeah, because it's root 2 over 2, root 2 over 2. Okay, so that makes sense to me. That's a line. You're just identifying the angle where the sine and cosine are the same. That's the idea. Okay? All right, this next one, we just do this. So x becomes r cosine theta. Y becomes r sine theta equals 1. Okay? Square it out. You're going to have r squared cosine theta sine theta equals 1. That's good enough. You don't have to do anything else with that. Okay? So that's fine. Okay? Nothing to it. Okay, let's go over doing this backwards real quick. And when you do these things backwards, you got to focus on this substitution. Okay, because we're trying to change this into, if I'm taking a polar equation, which has r and theta in it, into x and y, you typically use this substitution, and you still typically use these substitutions right here. Okay, so let me show you how you do this. So what you could do on this one is, there's more than one way to do this. You could square both sides of this equation. You could bypass this, but if you did it, you would have r squared equals 9. The reason I did this is because what's r squared? It's x squared plus y squared. So what you would get is x squared plus y squared is equal to 9. And that's a circle with a radius of 3. See, in polar, a circle with the center 0, 0, radius of 3 is just r equals 3. That's it. Just means go to the third circle and sketch it. That's it. Okay? Okay, the next one. Now, this is a real key on this is on this problem, you want to have, you see a sine theta, but it would be nice if that said r, if that said 10 r sine theta, then it would be easy to substitute. So what could you do to both sides so that would become 10 r sine theta? Just multiply by r, right? Okay, you're going to do this all the time on these. Just multiply both sides of this equation by r. See, this is the key to doing this, is to multiply both sides by r, because you want that to be in there. And once I do this, you'll see why. Well, that's r squared. This is 10 r sine theta. Okay, so what is r squared? X squared plus y squared. Okay, what is r sine theta? Y. That's why I did that. Okay, so now I get 10y, and then you're done. That's good enough. For what we're doing, it's good enough to just stop there. Okay, so if you have a sine, try to make it into an r sine. If you have a cosine, try to make it into an r cosine theta. That's the idea. Okay. All right, this next one, what I'm going to do on this is I'm going to put the r over 1, and I'm going to cross multiply. Remember, I want to see an r cosine theta there. So if I cross multiply, that'll happen. So now I just do r times 1 plus cosine theta is equal to 1 times 5. So if I do a distributive property here, that's going to give r plus r cosine theta equals 5 like that. Okay? Now, be careful about this now. Now, what is r? R is actually the square root of x squared plus y squared, right? Okay, so what you're going to do is we're going to replace that with the square root of x squared plus y squared. Okay, what's r cosine theta? X. There you go, have it. Now you're done. That's good enough. You don't have to go any further. Okay, I mean, you could isolate the radical and square both sides of the radical if you wanted to. All I'm trying to do is just kind of get you focused on the substitution. Then you can do basic simplification. Okay, so keeping that in mind, what you want to do on this problem, what do you want to do to both sides of this equation so that you get an r sine theta? Multiply by r. That's the whole key. You do that all the time on these equations. If you don't do that, you'll never get anywhere. So this gives r squared. That's going to be r plus 2r sine theta, like that. Now you're ready to substitute. So what's r squared? X squared plus y squared. R is square root of x squared plus y squared from the Pythagorean theorem. And then you would have plus 2, and what's r sine theta? That's a y. So that's it. So what I'm doing is I'm replacing r squared with what it's equal to, r with what it's equal to, and r sine theta with what it's equal to. That's it. Okay? You did this same stuff in trig, like right at the very end of the semester. It's like the last